Hi, CPSE 120. I've got a nice little lecture for you. What you're looking at is my computer. I've got my terminal set up over here. That's my terminal. And here's my text editor. This is my Linux computer. It looks a lot like a Macintosh, but I can assure you it is Linux. As you can see, let's start by reviewing what types we know so far. So let's make a list of all the types. Let's make this nice and big. Write this down. We know int, double, bool, standard string, whoops, standard string. And when we think of int and double, those are our numerical types. They represent numbers. Well, if I think of integer, I'm thinking of things like 0, -4, 42, 17, 17, -8. And then double is numbers that have decimal places and double represents like real numbers, so like 3.14, 5.2, -1.0, and also could do really large numbers because double represents numbers as scientific notation. And our bools, well, this represents yes, no, true, false. You know, it's either one thing or the other thing. It's a type that represents either being on or off, yes or no, true or false. And we can use it to, we can use bools to figure out whether or not we need to go this way or that way in our conditional statements, like our if and else's. And standard string, of course, represents strings such as hello, and the other stuff that's represented between the double quotes. And then recently we've been talking about these mysterious things, cin and cout. Now, you know they exist. We use them all the time. We're not quite sure what they are, but they do have some behavior. And last time that we had class, I showed you that you can ask cin if it's okay, and if it's okay, then it knows that it's taken in the right values and that it's a happy program. So let's start with our program that we wrote last time, and we can remind ourselves how we can ask cin whether it's okay or not. So I like to keep everything organized. I've got an empty directory over here for today's lecture, and I've already written a file called program.cc. And let's fill that file up with some code. Let's do a pound include for IOStream. Let's do a pound include for string. And let's write our main function out. And let us do what we did before. What we did last time was we had an integer variable called number. We just initialized it to some garbage. And then we had a prompt. We asked the computer user to type something in, to tell us something, a number, and then we use cin to read that value into number. Now, before, we used to start at the top of the program and work our way down, and we had to have faith that the computer user was going to do exactly what we asked the computer user to do. So if we prompt the computer user to enter a number, we count on them to type out a number, not a string, not a word or a color or something else like that. And if we ask them for a string, we count on them to type in a string, not a number. And if they did type in a number, well, that number would be interpreted as a string. So we were counting on the computer user to know how things worked, and cin would magically take in whatever was typed in and put it into this variable. And that variable type would tell cin how to read that in. Last time we learned that if somebody did a mistake, we could ask cin if it thinks there was a mistake and would give us some feedback. Let me show you how that works. So in class we did if standard cin. Oh, actually we want to do the exceptional case, right? If cin's not okay, and remember that the exclamation mark means not. If cin is not okay, then we're going to print out a message. And we're going to return immediately. Remember, when we're inside of main, when we return, it exits main. It exits our program. Our program always starts at the top and executes as it goes down, and will exit main, or exit an entire program when it reaches a return. When we reach the end of our main function, we return 0 to say, hey, everything's okay, everybody's happy. And when we return 1, that's signaling to the world outside of us that something went wrong. This is a way that we can phone home and let everyone know that things are okay, return 0, or something went wrong with return 1. So let's try this out. I've written this program. Let's go back to our computer over here. We can see there's the file. I can show you that the contents of these two things are the same. Let's compile it with Clang++, the old-fashioned way. I'm going to tell the compiler that I'm using C++20, and the name of the file is program.cc, and I let it think for a second, and the output will be a.out. So if I do /a.out, it will ask me for something. Let me type in a number, 42. Hit enter. Oh, I forgot to print something back out on the screen. Let's put that here. Because after all, if we get past this if condition, then we know number's okay and we can print it out. Let's see, number. \n, let's put a period there, make it look nice. Save this, let's compile again. Let's run the program, and we type 42, and we see 42. Perfect. Now what would happen if we wrote a color instead of a number? Let's say we picked orange. Now, because we typed orange, orange is a string, and when it tries to read it right here on this line, Cin is like thinking to itself, wait a second, this input doesn't feel or taste like an integer. How am I going to be able to take this stuff from the keyboard and read it into number, which is of type integer? Remember, C++ is a statically typed language, and everything is strongly typed, which means everything is typed. So we know that number is an integer type. Cin knows that number is an integer type. So when it does this magical conversion or this magical read from the keyboard, and it sees things that don't look like an integer, well, it's going to tell you it's unhappy. So if we ask it what's going on this line right here, hey, Cin, are you okay? When we say not okay, then we can go into this condition right here and print out that there was a problem and exit immediately. So that way the garbage that's coming into us doesn't get processed and our program can exit immediately. Consider for a second how all the programs we've used on the command line, like cd, Clang++, make, VS Code, CP, MV, can all magically know what we typed on the command line. These programs can somehow get the information we type transmitted to them and inside of the program to make stuff happen. For instance, when you do your lab assignments, you type make format, and make knows that you've typed format. When you type make unit test, make knows that you've typed unit test. In this example here, if I compile this program that I've written, and I say program.cc, magically Clang++ knows that the name of the file is program.cc. And when I run a.out, you know, I have to have a conversation with my program. My programs, the ones I write in 120, are the ones that I have to like have a conversation by typing stuff in and using cin and cout to get information from the computer user. But all the other programs that we've used so far, they always get their information from the command line. How is it that Clang++ can get something from the command line, but our programs can't? How is it possible that a program like Clang++ knows about what we typed on the command line? I mean, consider like it's a chicken and egg problem, because when I write this here on the command line, Clang++ hasn't started executing yet. If I type ls program.cc, this needs to be passed to ls in order for ls to show me that. If I want to type any command and pass some argument to it, there has to be something that connects it all together. And you might think that it's the shell. That it's this window here that somehow connects them together. And it's actually the operating system. The operating system knows about everything that's going on inside this computer. The operating system allows all these different things to happen. The operating system is actually being asked to run my program, a.out. The operating system is being asked to show onto this terminal the text prompt. And when I type something here, say for instance 56, and I hit enter, the operating system is talking to Cin and helping Cin get that information from the keyboard, and then storing it into that location in memory, into that variable. When I do something crazy and I write something like this instead of a number, the operating system is connecting Cin, the keyboard, to cin, and cin is noticing that there's a problem, and I can ask cin about this, but it's the operating system that controls all these different things. So if the operating system knows what I'm typing on the shell, the operating system might be able to provide us with the information that's typed here on the command line. It'd be a lot nicer. I could say, for instance, run my program and provide the number 42 on the command line and have it printed out, or the color orange and have it printed out, rather than having to run the program, type in the value, and then have it printed back out to me. Command line programs use what's called command line arguments to be able to get information from the computer user who's typing and put that into the memory of the computer program. Now, long ago, I promised you I'd explain what's going on with this. I said, don't worry, this is how main is defined. You just have to learn it and memorize it. But now I'll tell you why we have to do it this way. We define main this way because back when C and C++ were defined, we said the definition of main is the entry point to our program, but also the definition of main provides a way for the operating system to provide information. Remember, main is a function, and all functions have a name, in this case main. All functions have a return type, in this case int. Int returns, like main returns 0 when everything's okay, and returns something other than 0 when something goes wrong. And who's listening to this return value? Well, it's the operating system who wants to know what main is returning. Again, this is by definition. This is the way we've built the system to work this way, and it's been this way for about 50 years. Now, this other part that I said, don't worry, I'll explain it later. The explanation is these two typed and named parameters for this function main exist to allow the operating system to tell us what's written on the command line. Let's review for a moment how we define a function. If I want to define a simple function that adds two numbers, I might say the name of the function is add, and it has two parameters. I'll say left-hand side, LHS, and int right-hand side, and it returns an integer, the sum of those two numbers. And the body of this function will return the sum of left-hand side plus right-hand side. This little function here demonstrates the key parts of a C++ function definition. It has a name, it has a return type, it has a typed and named parameter list, and it has a body. When I use this function add, and let's imagine I use it over here, I would say something like this. I would, for instance, say add, and I'd give it two numbers, 12 and 24. Add, the function is called, and these two values get copied into these two variables. They are then summed, and that value is returned to whoever called it, which would be right here, meaning number will take that value. When I run my program, what happens is the shell is asking the operating system to execute this program. And the operating system says, oh, great, you want me to run this program? Hey, this program exists. I'll look inside it to find the main function. And when it finds the main function, it copies in data, it fills argc and argv with whatever I type on the command line. Whatever I type in the command line magically gets transmitted to argc and argv, and then I can use those values in my program. So now you know that it's argc and argv. So there's these parameters to main that we're going to use to somehow get information from the operating system. Let me just write down what these guys mean. argc is an integer type, and it is a count of how many arguments are on the command line. And then argv, that's the second one, is a list of words or strings that represent everything that's on the command line. Now, we know what an int is. No problem there. We don't know what this is. Like, we understand that this is the variable name right there, argv. We don't know this char star and this bracket stuff. And we don't want to know. Some of you might know about this from some independent reading or studying that you've done, but in our opinion, for 120, this is old-fashioned and we don't want to use it. So what we're going to do is we're going to take this information that comes from the operating system and we're going to repackage it. Now, the important thing to consider is we are not just getting one piece of information, we're getting a sequence, a whole bunch of stuff. And so we need to hold a whole bunch of stuff in one place. Think about like if you go to the supermarket and you want to buy a whole bunch of different things, you typically bring a shopping cart. You might bring your own bags. You might bring a backpack. You might bring some type of container so that you can fill that container with all the things you want to take. If you go on a trip, you don't just take your clothes and hold them in your hands. You probably get a container and put the clothes that you're going to take on your trip inside that container. We've got different types of containers to do different sorts of things. And in this situation, because we're using what is, this is kind of like pretending to be a typewriter, we're going to need a container that's going to hold words or strings. So if I type a command and I give it different arguments, like first command argument, second, third, or I give a command and the command takes different colors like blue, red, and orange, I need to contain blue, red, and orange into some container that will hold it. Now, we know that we can use the string type to hold words. We're going to need something else from the standard library that will hold a sequence of words. The type that we're going to talk about is called vector. To use a vector, we need a new header file called vector. And to our list of known types, we're going to add standard vector. Now, when I write standard vector, it's very important to notice that there's these angle brackets right there because between it, we're going to put what's inside of that container. Remember, C++, strongly typed language, everything is typed and it's statically typed. So if I've got a container of something, that means that container is going to contain only that one thing, and it's always going to contain only that one thing. And this is something that we count on whenever we go to the supermarket. You walk down the aisles and you pick up a bag of potato chips and you look inside that bag, which is a container. There should only be potato chips. There shouldn't be any yogurt. There shouldn't be any juice. There shouldn't be any corn chips because that is a container of potato chips. You pick up a container of yogurt. There should be no orange juice in it. There should be no mustard, no ketchup, no potato chips or corn chips. That should just be a container that contains yogurt. So when I create a container in C++, a vector container, I will specify what goes inside that container by putting that type between the angle brackets. To give you an example, I'm going to say standard vector standard string. That's my type. This type is a container, a vector, that holds strings. The variable name is, well, in this case, I want to represent my command line. So I'll call it command line. That's how I declare it. This is a variable called command line. It is of type vector. And a vector is a container. And inside this container, we'll find only strings. We'll find only strings. So now that we know how to declare a variable that will be a container of strings, our next challenge is how do I get the stuff that's coming from my operating system, that's the argc and the argv, how do I get that copied into command line? And this is something we just have to memorize. And here, I'm going to remove all this stuff here. This is our old program. Our new program is going to use command line arguments. And I'm going to break this up onto 2 lines so that you can see how I initialize my command line. Like all C++ things that we've been working with, like whether it's integer, double, string, or bool, we use braces to initialize it. Now, because it's a container, and the container contains many things that's coming from the operating system, or perhaps nothing coming from the operating system, we have 2 arguments that we give to this initializer. We say argv, comma, argv plus argc. Now later I'll explain why we do that, but know for now that if I want to get information from the command line, from the operating system, of what was typed inside the shell, then I can use this line right here to be able to take argv and argc and massage it into a new variable called command line. It's of type vector and it contains strings. So before we go on, let's compile this and make sure that we didn't make any typos. Yeah, great. Now, of course, this program doesn't do anything, but we can perhaps start asking command line about itself. Say, for instance, I want to know how many command line arguments there were. I can say standard cout command line size. Now, let me put some more context here. So I'm going to print out the command line is, and then I'm going to ask the command line how big it is. The command line is a vector type, and the vector type can understand messages that we send to it. I can ask the question, what is your size? That notation there is saying, command line, please tell me what your size is. And it's going to return back an integer, and I can print that out. So let's save this, compile our program one more time. If I run my program, it'll say the command line is 1 long. What happens if I put a bunch of different colors here? Blue, red, orange, green. Now it's 5 long. Let's check this out. Look, I put 1, 2, 3, 4 different colors there. Again, 1, 2, 3, 4 different colors there. Yet it says it's 5 long. And over here it says it's 1 long. The important thing to note is that the command line also includes the name of the program itself. So that's going to get counted. If we count that, it goes 1, 2, 3, 4, 5. Let's try it again, and let's give it numbers. How about 30, 40, 50, 60, and 70? So the command line is 6 long. That's 1, 2, 3, 4, 5, 6. Now the next thing you might want to do is you might want to print out what's inside of the command line. Now, every time you run a program, you're guaranteed to have at least one argument, which is the name of the program. So it's safe to print out the first or the 0th, because remember in C++ and many other programming languages, we start counting from 0, not from 1. So the 0th index, the 0th location is the first item in the sequence. I can print it out. Let's put quotation marks there. To find out what's at that location, I say at, and I give the index of what I want. Some of you might know about the bracket notation. Please do not use the bracket notation. The bracket notation is not what we use in CPSC 120. Please, please, please do not use the bracket notation. I don't need to show you what the bracket notation is because I don't want you to use it. If you've seen it before and you've used it in the past, that's great. But from now on, do not use the bracket notation. Always use .at to find out what's at a specific location. So let's save this and let's run our program. Let's compile and run our program one more time. Let's do a.out. Hey, let's try some colors. So it's going to change the length given how many arguments I give on the command line. But it's not going to show me anything other than the 0th item because that's the only one I'm printing out. Let's imagine that I want to have a program that's going to take one command line argument or only one command line argument. What I might want to do is I might want to check to see how many command line arguments there are first, and if there's not enough, print an error message, and if there is, print out the command line argument that I'm interested in. So we know the 0th command line argument is always going to be a.out because the 0th item is always the name of the program. Let's do a check. If our command line size is, okay, let's think for a second. I want to have a command line that will look like this. It will always have one command line argument. So if I run it, it needs to be too long. If I add another thing there, green, it becomes 3. And if I have one too few, it's 1. So I need to make sure that I have at least 2 arguments. So if the command line size is less than 2, that means I have a situation where it's too short and I don't have that extra argument, the extra argument that I want. Let me recap just so I can make it clear. If it's too short, it will look like this. If it's too long, it will look like this. And if it's just right, it will look like that. And since it's just right, I want to have the length to be 2. So I can say equal equals to 2, same as 2, but I just want to make sure it has at least 2. If it's got at least 2, then I know I can print out what is at location 1. Let's recompile. Oh gosh, this broke. So this is an important thing to notice, that I didn't give it enough command line arguments. And if I go past the end of the vector will throw what's called an exception. Let's trace through my code. Where did this occur? So here's where I create the vector. Here's where I print out the size, right? That worked out. Here's where I say what the 0th item is. That worked out. That's right there. And here's where I check to see if the size is less than 2. If it's less than 2, I'm going to print. Wait a second. My logic is all wrong here. Because I'm checking to see if it's less than 2, and this is less than 2, it's going to try to print something that doesn't exist. That's exactly what I'm trying to avoid. So if I make a mistake like this and I use the @ notation, the vector is going to throw an exception, and I can trace through my code very carefully and identify where I went wrong. So what I want to say here is, if the command line is less than 2, I'm going to first remove this line right here, and I'm going to paste it right below. If the command line is less than 2, I've got too few arguments. And I'm going to return 1. Otherwise, I know I've got enough arguments to print the command line argument that comes after the 0th location. Let's try that again. Let's compile. A.out, and this should be too few, right? Because there's only 1 command line argument there. And it says too few arguments. Now let me try it with 1 argument there. Hey, this works nicely. It's 2. It prints out the 0th and the 1st, and it prints out blue, and that's what I wrote there. Let's try this again, and I'll change this to other colors, orange and red. So even though it's longer, it only prints out the 0 and the 1st. And if I put too few, meaning I don't have enough arguments there, it's going to reach that if condition, too few arguments, because it is too short, and it's going to return 1 and exit before it gets to this part here where I go off the end of that sequence. Now, this is our first introduction to using command line arguments. This is just a taste. There's a lot of stuff that we can do with command line arguments. We're going to explore it further, but I just want you to know that we can now write programs that can take information from the command line, what we type over here, and process it inside of our programs. And we can massage this old-fashioned data that comes from this standard that was written 50 years ago into something that's modern using this new type called a standard vector. And to use vectors in our programs, we need to pound include vector at the top of our file, and we always need to provide the type that goes inside the vector. And remember, vectors can only contain one type and one type only. Let's try writing a program using command line arguments and do that the if else stuff that we did the other day, looking at what we're going to eat depending on what day of the week it is. So I've got my file program.cc right here. I've got to open my text editor. Let's put our pound includes at the top. I need IOStream if I want to print stuff out. I need string if I'm going to work with strings. And now I need to include vector if I want to create a container that contains like a sequence of something. I want to be able to process command line arguments, so I'm going to create a vector of strings here. So I say standard vector angle bracket standard string. This is the type. The type is a vector of strings. That's how I read it. It's a vector of whatever's inside the angle brackets, strings. The name of the variable, command line. And the way I initialize it is by saying brace argv, comma, argv plus argc. This is something you just have to memorize for now, and later I'll explain what it actually means. But this will copy whatever's on the command line that the operating system's put into these two variables, these two very special variables, and put it into a variable that is easy for us to use in 120. Now, I need to have at least one command line argument. One command line argument means that I need to have the program name plus the name of the day. So it would look like something like this. I'd say a.out, and I might write Tuesday or Monday. And I need to have one argument there. So remember, the way this is going to work is a.out is the 0th location, and Monday would be the first location. And this would be a total of 2 elements. So argc would be the same as 2. Notice that this would be the first one. This is the second one. So 1, 2. So argc is 2. And our command line at location 0 would have a.out, and at location 1 would have the day of the week. So to make this happen, we're going to have a condition if command line size is less than 2, then we've got a problem. We have too few arguments. And if I have too few arguments, I need to exit immediately because there's no point in going forward. Now, if I've got enough arguments, then I'll make a variable. I'll call it today, and I'll initialize it to command line at location 1 because the day of the week will be at location 1. If today is Monday, then we'll eat, what should we have on Monday? Hamburgers. That's what we'll have for dinner on Monday. Else if today is Tuesday, well, what are we going to have on Tuesday? Well, of course, tacos. Else if today is Wednesday, what should we have on Wednesday? Well, let's have pizza. And I guess we used all our money eating hamburgers, tacos, and pizza. So for the rest of the week, all we can afford to eat is cold cereal. That's a bummer. So we're using the if else that we learned earlier, and we're using the same as operator to check to see if today is the same as Monday or Tuesday or Wednesday. And we have an else to catch all other days of the week, so that would be Thursday, Friday, Saturday, and Sunday. So let's save this file and let's compile it. If I run it without enough arguments, I expect it to say too few args. Yeah, too few args. Now let's give it something that doesn't make sense. Green is not a day of the week. So I guess I'm going to eat cold cereal. Let's walk through this. So it got past this if condition. It took whatever I put at location 1 and put it into today, and then it went through all these conditions. Now green doesn't match Monday, green doesn't match Tuesday, green doesn't match Wednesday. It hit the else, and it printed out cold cereal. We can see that right there. Let's try doing Tuesday. Hey, we'll get tacos. And if we try doing it on Monday, we get hamburgers. On Wednesday, we get pizza. And what about Friday? Yeah, cold cereal. So now we've got a program that takes input from the command line, puts it into our own container, our own vector, pulls out that information, and then we can use that information in a series of conditions to make our program do different things depending on what the computer user inputs. And we don't need to do this C in, C out business anymore. We can just provide that input on the command line and get immediate results right then and there.